The domain of a function. The domain of a function is the set of all possible input value for which the function is defined. Think of a function like a machine that takes inputs and gives outputs. The domain is simply what inputs can this machine handle. Now, when is a function not defined? A function is not defined if the denominator of a fraction is 0. Say we have a function f of x equal to 1 over x. When x is equal to 0, then such function is said to be undefined. A function is also said to be undefined when we have a negative number under a square root. Say we have a function f of x equal square root of negative x. We know it is impossible to take the square root of a negative number. Therefore, such function is said to be undefined. A function is also said to be undefined when we have a log of 0 or negative number. If you take your calculator and try to take the log of a negative number or 0, you see that it brings no result, meaning that it is undefined. Now, let's look at the domain of a linear, quadratic, and polynomial function. For a linear function like f of x is equal to 2x plus 1, a quadratic function like f of x is equal to x squared plus 3x plus 2, and a polynomial function like f of x is equal to x cubed minus 4x plus 1, their domain is all real numbers, that is, from negative infinity to positive infinity. And this is because you can plug in any real number and get a valid output. So, a linear, quadratic, and polynomial function are all defined for all value of x. Now, let's look at the domain of a square root function. A square root function is defined when the expression under the square root is greater than or equal to 0. Therefore, to find the domain of a square root function, we simply set the expression greater than or equal to 0. Now, let's take this example. Here, we have that f of x is equal to square root of x minus 16. To find the domain of this function, we set the expression x minus 16 greater than or equal to 0. Adding 16 to both sides of the equation, we have x is greater than or equal to 16. Therefore, the domain of this function is all real numbers greater than or equal to 16. To write the domain in interval notation, draw a number line. At 16, place a closed circle indicating that 16 is part of the domain. Shade to the right, indicating that numbers greater than 16 are also part of the domain. So, in interval notation, the domain of this function can be written as this. Note, this bracket here indicates that 16 is also part of the domain. Now, let's take this example. We have that f of x is equal to square root of x squared minus 9. To find the domain of this function, we set the expression x squared minus 9 greater than or equal to 0. To make solving this easier, let's change the inequality sign to an equal to sign. Doing that, we have this. By difference of two squares, this becomes x minus 3 bracket x plus 3 is equal to 0. Then we have x minus 3 is equal to 0, or x plus 3 is equal to 0. Then this becomes x is equal to 3, or x is equal to minus 3. Next, we put these values s equal to 3 and s equal to minus 3 on a number line. We mark a closed circle at minus 3 and 3 since they are included in the domain. On this number line, There are three intervals, which are from negative infinity to negative 3, from negative 3 to 3, and from 3 to positive infinity. So, what we are trying to do here is to find which of these intervals is part of the domain. Now, to do that, we need to take a test value from each of these intervals to substitute into this expression. If we get a positive value for an interval, then that interval is part of the domain. So, for the first interval, which is negative infinity to negative 3, let's use let's take minus 4 as our test value. For the second interval, let's take 0, and for the third interval, let's take 4. Note, any value you are using as your test value must lie within these intervals. As you can see here, minus 4 lies within the interval negative infinity to negative 3, and 0 lies within the interval of minus 3 to 3. So, for the first interval, we have to use minus 4. Substituting minus 4 into this expression, we have minus 4 squared minus 9. Minus 4 squared gives us 16. So this becomes 16 minus 9, and that is 7. 7 is a positive number. Since we have a positive number here, then the interval negative infinity to negative 3 would be part of the domain. Now, for the second interval, using 0, we have 0 squared minus 9. And this is 0 minus 9, and this gives us minus 9. Since minus 9 is a negative number, then this interval is not part of the domain. Now, let's try the third interval using 4. Substituting 4 into this expression, we have 4 squared minus 9. 4 squared is 16. So this is 16 minus 9, and that gives us 7. Since 7 is a positive number, then this interval is part of the domain. So the intervals that are part of this domain are negative infinity to negative 3 and 3 to positive infinity. To write this in interval notation, we say the domain is from negative infinity to negative 3 union 3 to positive infinity. As you can see here, we used a bracket and not a parenthesis, indicating that minus 3 and 3 are also part of the domain. Now, let's talk about the domain of a rational function. For a rational function, we have a fraction, and for such function to be defined, the denominator of the fraction cannot be equal to 0. Now, let's take this example. We have that f of x is equal to 2x plus 3 over x squared plus 5x minus 4. Here, we have no restriction at the numerator since we have a linear function there, and a linear function is defined for all value of x. So, the only restriction here is that our denominator cannot be equal to 0. So, to solve this, we set our denominator not equal to 0. So, this becomes x squared plus 5x minus 4 cannot equal 0. Factorizing this expression, we have x minus 2 bracket x plus 7 cannot equal 0. And this becomes x minus 2 cannot equal 0, x plus 7 cannot equal 0, and this becomes x cannot equal 2, or x cannot equal minus 7. The domain of this function is all real numbers except 2 and minus 7. In interval notation, this can be written as everything from negative infinity to negative 7, but not including negative 7, union everything from negative 7 to 2, but not including negative 7 and 2, union everything from 2 to positive infinity, but not including 2. Now, let's take this example. We have that f of x is equal to x squared plus 3x plus 2 over x squared plus 7. To solve this, we simply set the denominator not equal to 0. So this becomes x squared plus 7 not equal to 0. Subtracting 7 from both sides, we have x squared not equal minus 7. Since it is impossible for the square of a number to give a negative result, then the domain of this function is all real numbers, that is, from negative infinity to positive infinity, because no value of x would produce 0 in the denominator. Now, let's look at this example. We have that f of x is equal to x squared plus 3x plus 2 over square root of 2x plus 1. Here, we have a square root in the denominator. Whenever we have a square root in the denominator, we simply set the expression greater than 0. Normally, for a square root function, we set the expression greater than or equal to 0. But since the square root is a denominator of a fraction here, it cannot be equal to 0. So, in this case, we set it greater than 0. So, this becomes 2x plus 1 greater than 0. Subtracting 1 from both sides, we have 2x is greater than minus 1. Dividing through by 2, we have x greater than minus 1 over 2. So, the domain of this function is all real numbers greater than minus 1 over 2. In interval notation, we can write this as from negative 1 over 2, but not including negative 1 over 2, to positive infinity. Now, let's look at this example. We have f of x is equal to square root of x squared plus 5x minus 14 over x plus 2. For this function, we have a restriction at the numerator and at the denominator. For this function to be defined, the expression x squared plus 5x minus 14 must be greater than or equal to 0, and x plus 2 must not be equal to 0. Subtracting 2 from both sides of the equation, we have x cannot equal minus 2. Factorizing the expression here, we have x minus 2 times x plus 7 is greater than or equal to 0. This becomes x minus 2 is greater than or equal to 0, or x plus 7 is greater than or equal to 0. And this becomes x is greater than or equal to 2, or x is greater than or equal to minus 7. So we have x cannot equal minus 2, x greater than or equal to 2, or x greater than or equal to minus 7. To find the domain of this function, we need to take the intersection of these three values. To do that, we put these numbers on a number line. We mark a closed circle at minus 7 and 2 since they are part of the domain, and a closed circle at minus 2 since it is not part of the domain. On this number line, we have 4 intervals. So we are going to pick a test value from each of these intervals to substitute into this expression. For the first interval, let's use minus 8, the second minus 3, the third 0, and the fourth 3. Now, to make this easier, let's use the factorized form of this expression. Substituting minus 8 into that expression, we have minus 10 times minus 1, which gives us plus 10. Here, we have a positive number, so this interval is part of the domain. Now, substituting minus 3, we have minus 5 times plus 4, and that gives us minus 20. Here, we have a negative number, and since we have a negative number, then this interval is not part of the domain. Substituting 0, we have minus 2 times plus 7, and that gives us minus 14. Since we have a negative number here, then this interval is not part of the domain. Substituting 3, we have plus 1 times plus 10, and this gives us plus 10. Since we have a positive number here, then this interval is part of the domain. So the intervals that are part of the domain are negative infinity to negative 7 and 2 to positive infinity. In interval notation, we write this as everything from negative infinity to negative 7, including 7, union everything from 2, including 2, to positive infinity. If you find this video helpful, drop a comment, like, share, and most importantly, don't forget to subscribe.